This meeting is being recorded.
All right, so session 2 on the two-wheeler robot proposal. We should give it a name. So you thought of it, Yasha, so you should give the robot a name.
Oh, that's not a good idea. Yeah, I think are we going to Mars or the moon or both? Where does this go?
I think we're starting with the Mojave Desert, right?
Yeah. It's going to be very slow, and it has a tail. So it's sort of like a, I don't know, I don't want to call it a tortoise, but it's some kind of, I think there should be a sort of organic animal name to it. Think about it. Let's think about what that simmer, and then at the end of the call we could name it. Okay, so the next step here in kind of like my opinion is I think we should figure out a way to divide and conquer our efforts a little bit if we are going to converge on this platform. So there's a number of things that were going on in the chat and discussion, such as like selecting the compute. Right now, we're still in the component selection and architecture phase of this robot. And a lot of that activity in itself can be kind of like split out into people. So if like somebody wants to think about what compute to select, if somebody wants to think about how to deal with the lizard brain to big brain kind of like handoff or challenge, and or actually selecting the components for the lizard brain and big brain. In addition, I think the one thing that we definitely don't have, or at least as in my understanding isn't nailed down, is the mission objective, at least for the measurement. So what is this actually measuring? Also, apologies, I'm a little stuffy and I'm not feeling the greatest. So if I'm hard to hear, I apologize.
Yeah, this is where we left off last time. I had just opened up this spreadsheet, and I think I captured some of what we were talking about, but what you just mentioned, the mission tab is basically empty. So
this is the starting place. Yeah, we should start here. Yeah.
So I think when you originally proposed this direction, you talked about radioactivity as the potential thing to build the mission objective around. So maybe backing up a little bit, what's the system design driving component? Will it actually be the payload sensor? Like if it's radioactivity, I imagine a Geiger counter is a pretty heavy component or something.
I mean, what I'm getting at is if the mission is kind of the driver, because I know, okay, so there's sort of the directions we're getting pulled in, right? Which is the kind of vision of modularity or like multi-mission capability. And then the other side is like a specific mission and payload and capability. So for a Geiger counter, that's actually, it's kind of an interesting one, because depending on what you're measuring, the constraint might not only be the power or the weight, it might be kind of like the physical orientation. So depending on what you're measuring, like if it's gamma, that goes through everything, and then the sensor can be mounted anywhere. But if you're measuring more local things like beta, that might actually need to have a more deliberate sort of placement on the vehicle and what it's measuring, right? Because that doesn't have quite the penetration power as a higher energy particle. But it just depends. Like, this isn't necessarily the mission. Maybe this is not an interesting mission. This is just an example of what I would call, it's kind of like I haven't thought of a name to call it. There's this interesting area in, the sort of new bots that I consider to be like, is it an IoT sensor, or is it a robot? Because it's mostly just like a sensor that grew wheels. And like my favorite canonical example of that is the YakRover, which is this. It's like a grain weevil that goes in grain bins and measures the gradient of temperature and humidity. Whereas traditionally you would create strings of many sensors and like stick down through the entire bulk of the grain and measure it with fixed infrastructure, versus now you have a sensor that can move and take measurements dynamically. So in this case, it would be like, instead of laying down strings of Geiger counters, you'll have like one mobile Geiger counter that can spatially map given a low temporally shifting environment. But yeah, maybe there are other environmental things we would want to measure that are interesting. I don't know. Have there, on any other calls been mission concepts or I don't remember any time we've really talked about like, what do we actually want to do? Do we want to manipulate? Do we want to like dig tunnels or make a structure?
Well, we had a session for the natural robotics contest in which Venkat's entry got selected for something. So that was basically designing different kinds of rovers for different kinds of mission.
Oh, sorry, was there?
Sorry. Yeah. So I guess that's a little sidetrack worth mentioning here, what Anurag just mentioned. So last year there was that contest on like bio-inspired robotics, and we sent in a couple of ideas, and Mayor just posted that one we sent in got featured as one of them. Where is it? Can you guys see all the tabs on my screen?
Yes.
Okay, so this one is.
If you search for Yak, you will find it.
It was my idea. It was completely random. Since heat shields are discarded on Mars, can you use them to improve the covering of another rover? But yeah, there might be some ideas in here. But I think for us, seems simpler to have like pure sensor mission. So maybe that's a mission design question, which is the spreadsheet is a mess, but sensor only or actuation. So that's a parameter question. I would say sensor is much easier if you're doing anything like tunneling or scavenging environmental materials to enhance yourself. That's like a couple of levels more complexities. A sensor only robot doesn't even need like any kind of like actuator, gripper, or anything, right?
Well, finding white water or ice seems to be an okay mission.
I'm just going to take unstructured notes here.
Because that is an actual scenario on Moon or Mars, where the rovers need to find some ice or water deposits.
Yeah, that's why don't we brainstorm the top level potential objectives here. These are the ones I've heard so far. Anything else people want to dump in this?
Isn't SpaceX planning to do some fuel for the rocket based on some materials on Mars?
Yeah, I would say, I mean, obviously it's a surface measurement for probably our initial purposes, but doing any sort of analysis of the material can be interesting, and that can either be extraordinarily complex or extraordinarily simple. So like fluorescence microscopy or yeah. fluorescence spectroscopy or optical spectroscopy. There's all sorts of things you could do that are either invasive, require special equipment, don't require special equipment.
What about how much can you do with just a camera? What if the only sensor is a camera and it's gimbaled? So for navigation, it pivots up to look forward, and for like science, it pivots down to look at the ground it's rolling over. So
I mean, in the desert, you could do all kinds of interesting things. Like, well, it might be kind of cool as a plant inventory. It could inventory the environment, which is sort of interesting.
How small the hyperspectral cameras can get? Because these days CubeSat send them.
Yeah, so if you InGas is very expensive. It's not the size, it's the cost. So it's like, this kind of comes back to, what do you want this thing to cost? If you want it to be $200,
Oh, okay.
that's gonna be a no-go. But if you want to spend a couple thousand on it, then that's a lot more interesting.
I think we can go to a couple of thousand. We have savings in the YAK fund, which we can draw on, and I'm willing to kick in a couple of $100 as additional contribution from the rover team. So I think, by the way, that's going to be the financing structure of this if it becomes more serious, which is we'll ask YAK Collective for a grant, basically, and we have like a rudimentary voting procedure. So we can probably get like maybe $1,000 from there, and then maybe we each kick in a little bit of money. That gives us maybe a $2,000 budget. And if it gets more ambitious and we actually show progress, we can always like open it up and get people to contribute more. So people who want to support the project. So I would plan around a $2,000 mission if you're serious about this.
I actually would pretty strongly suggest, I mean, there's at least in my experience and career so far, it's almost always been a mistake to not go to the field earlier if you can. So if there is a mission which has any level of interesting properties, which can be achieved with less money and faster, that is the first move, because especially if you're talking about almost a 10x difference in the vehicle cost, that means you've already have robots in the wild doing their mission while you're designing the next robot, which is more expensive and higher stakes. So like shipping it with the stakes being lower and faster is always a win, at least in my experience.
So you mean the mission could be broken down into milestones that are increasingly more and more complex toward the full mission, right?
Yeah, because like the nice thing is we're not actually building flight hardware. So like to self-impose more pressure and constraint on the vehicle is not productive, at least in my opinion. So that will just make, because this is the thing, when this robot goes to the field, it'll be like night and day the things that we learn. Like there are things that will happen in the field that no amount of planning or meetings could ever have foreseen. So that's the thing that'll be cool, is it's like, oh, we have 5 robots out there doing their thing, and then that will be a completely different discussion, having that actually being an ambient amount of execution.
Yeah.
So maybe it's worth discussing what's the parameters of the very first, as quickly as possible, get it out there robot mission. I think there really the only minimal constraints we should put on it is an endurance parameter, how long it can stay out in the field, a temperature range parameter, and pick the simplest possible sensor that can possibly do something useful, which sounds to me like a camera. So 2 wheels, a camera, maximum temperature of 120 Fahrenheit, something like that. Does that sound like starting point. Maybe, oh, we were talking about this, Red and I, in the Discord, which is the solar power pack that you showed. What's the system constraint that creates? Is it something like charged for 8 hours in the hot sun and you get 15 minutes of roving out of it? Something like that? Like, what's the driving there?
Oh, that the free trade show power bank. Yeah, the trade show power bank is probably some duty cycle like that, but yeah, I mean yeah, look, it depends a lot on yeah, how much roving you want to do. Like, I bet you in full noon sun, the vehicle could very easily just have a continuous duty. That's probably true. So if it's generating, you know, like 2 to 3 watts, or maybe even 1 to 2 watts, that should be enough to like ambulate, probably at 100% duty cycle. Not quickly, but so it also just depends. It's like, is it you know, is it a daytime only mission or is it nocturnal? That's part of the question. If it's a cameras only mission and it doesn't need to bring its own light because illumination is very expensive, so it's like maybe it only works in the day. Maybe the things that we're trying to look for, we do need to bring our own illumination, so it only is nocturnal and it takes photos of the plants at night. So these are the sort of questions that will emerge.
So
But
day night, it sounds like there's two basic strategies, which is you charge in the day and use the power during the night. That's one way to do it. Or you do full only daytime and at nighttime you just hibernate. And the difference comes down to the cost of like providing illumination or using sensors that work at night, something like that, right? But what's special about nighttime roving? Like, what can you do with nighttime roving that you can't in daytime? More cheaply, like, so night behavior of plants, is that what kind of thing?
the nighttime roving, yeah, I was gonna say for some measurements, like the sun can be an issue. It can either be an asset or a liability. So it's like, if you're doing camera stuff, the sun can, if you can take your measurement in the full sun, that's great, and you get free photons. But if the sun actually messes up your measurement, then you have to spend energy generating your own photons at night with illumination. Or, you know, like a lot of sensors will like cut out the sun's filters, right? They'll filter out the sun because the sun is just completely undesired. And that's how you do stuff in the day. But yeah, because like there's a few things. You know, how is this, how is this actually moving? Does this have a brain to do autonomy on the device, or is it gonna like take a picture and send it to some server, and then the server sends it a command of where to go? Those are all things that will become very interesting and real in practice with you know, units in the field.
Well, in the beginning, it's maybe better to send it to the server, but then we can, as we maybe make a more expensive one, then we could have some more autonomy there.
So if I were to think of the simplest possible configuration, I would say no telemetry. You just drop it off in some drop-off location and give it some absolutely brain-dead simple wandering pattern, like, you know, do a random walk or something like that. And then you go find it and pick it up again. And in the meantime, it's been storing all its data on board. So you retrieve it and get the data, which means, and in terms of like location and navigation, it doesn't even need GPS because it kind of doesn't care where it's been. So that's the simplest solution, but that would make it hard to find later if it wanders off. And I don't know, if the range is like a mile, that's a lot of area to search to find it again. So probably locating it through, so I guess simpler than, so there's navigation capability, which is, I guess, GPS. versus others, but also something like homing beacon or something. Like once it's, so think of the simplest, here's my idea of the simplest mission. You drop it off somewhere, it has no like GPS or anything. It just wanders, does some stuff. And when it's done, it basically uses its remaining power to turn on a homing beacon. And then we use that to find it and pick it up again.
This is one thing that I would definitely push pretty hard on this one. I do think it has to have live telemetry.
Okay.
And there's like a long list of reasons for that. The biggest one I would say is just for the group, because could you imagine if we like build it and ship it and then we'll all kind of like be here thinking, huh, I wonder what it's doing. And then, you know, there's also kind of like the project traceability and PR piece, because it's like, oh, there's actually live things. So there's a lot of different ways you can actually get telemetry out of the desert. Like one, there's just a lot. So one of the I think easiest questions is, do we have a mission constraint to only go where there's cell reception? Because if we can use cellular, that makes a lot of things really easy for the telemetry. If we can't use cellular, there are still a lot of other options, but the power and cost and data rate constraints become more serious.
I think, yes. What's that company? Is it Particle or something that produces boards that connect to cellular? There's a bunch, right?
Yeah,
there are several of them.
Don't use Particle. We could use the Blues no card. Yeah, don't use Particle.
Wait,
There is also a good one from Nordic Semiconductor, so it has.
Yeah, but we can just use this guy. It's $100.
what is it called?
The Blues no card.
Blue Snow.
Blues note card. Yeah.
Okay, yeah. So I would say cell reception is actually not as strong constraint, because if you, maybe not in Mojave, I don't know the highway situation there, but on the road from LA to Vegas, it goes through lots of like extremely good cell reception area that's cutting through harsh desert, basically. So if you pick roving target domain that's close to a major highway, but make sure it doesn't go on the highway and get crushed, I think you're good. You'll get cell reception and you'll have like a nice wild desert environment.
Okay, cool. Yeah, because like actually seeing what they're doing and like knowing the fleet health, also because somebody will steal them and it'll be fun to like watch them steal it. It'll be very interesting, right, to see all that happen. So like stuff's gonna happen in the field. Like it'll be exciting.
So theft risk means one of two things. One is we either put defenses on it, so like maybe just put an Apple tag on it so that later we can track it or something, or like, I don't know, put in some interesting skunk technology where if somebody comes close, we spray it with some skunk juice. With theft risk also, I guess the main mitigation is make the rover as cheap as possible so we can just have like 2 or 3. So we can afford to do one, right?
Yeah, that's another justification for it being cheap.
Right.
But I think an AirTag is actually a good idea. You can like hide it very securely in the chassis and they won't even know it's there. And then we'll know. Then the rover has like an adventurous journey through the criminal underworld.
Yeah, and that's also why having telemetry on the device is critical, because then you learn all these things.
Oh, is an AirTag, it just needs to be near a cell network for an AirTag to work, or does it need to be near an Apple device? How does that work?
It has to be near an Apple device, and AirTags, it's a whole thing. But yeah, I mean, it wouldn't hurt to put an AirTag on it. Like, why not? It's not that heavy.
So you said telemetry is a must-have, and we're going to use something like Nordic Semi or something. But does that include GPS capability, or is that yet another little board we have to add?
Adding GPS is I would consider to be like a commodity. There's a lot of different ways. Like even this board with the note card, this has a GPS receiver. So this already has GPS already ready to go. So this is cellular and GPS. Like this is a GPS tracker already. And yeah, so yeah. Because yeah, there's all this stuff that comes up, right? We'll have like a we'll have to have like a fleet dashboard where you can see all the robots and where they're going, and have to have a place to store all the data and telemetry coming from them. And so all of this stuff just like naturally kind of emerges.
The Red is already kind of building a dashboardy thing, so that sub project can be pivoted there. All right, so we don't need. So I'm trying to spec out like the strawman version of the minimum viable deployable rover here.
So will we want to actually send images back? Sounds like that's a yes.
Images on the telemetry link.
Oakley will consume a lot of power, I guess. There are simpler cameras available, so we don't need like Oakley yet.
Yeah, that depends on the big brain versus the lizard brain. You know, I was thinking something like a ESP32 cam level of power.
All right, you already picked motors, right? Yasha was.
I do have, yeah, like a candidate motor. Yeah, candidate motor for sure.
Do you have that already? Like, can you put it on the spreadsheet?
Yeah, let me pull up part number. Yeah, just give me a second. I'll pull it up. I can tell you I've forgotten the yeah, if you search like JGY 370. That's like a very, very common motor. And some of them include an encoder on the end, which is what we would want.
All right. Oh, and battery power, are we going to use something similar to what you showed? Rhett was looking up, he found a bunch on Amazon. They're basically solar powered cell chargers, I think, right?
Yeah, so with regards to the battery bank, this is a kind of a key question that I have is whether or not we would need to go with any custom hardware here. I do think the answer is probably yes, because if we do want to actually have a more serious computer or level of compute on the device, we need to be able to turn it on and off and completely cut off its power. And the power bank is not going to give us any of that flexibility or control. So we would probably use an off-the-shelf solar charger, and then we would just use the battery rail straight off of that thing, and then that would go into our own little board. Unless I'm missing something, like that could be something. Please, somebody, if somebody wants to look for a way to manage power, that would be a good activity. It's not the most intense board to design, but it is definitely some hardware we would have to have for sure.
I like the idea of picking one functional area where we do something not off the shelf, and this seems like a good candidate. Everything else is off the shelf, just buy it and integrate it. But this one, it would be nice to have, yeah, battery power seems like a good candidate for some custom design.
Yeah, and it could even be something really simple that like, if the battery it does on a schedule, like it schedules when it turns on power to the big brain. It could be something that dumb, but it does have to. There has to be something which is like managing the power. Otherwise, it's not going to make it.
All right, so that sounds like it would be the hard bottleneck activity. So this and the telemetry dashboard seem like the two pieces of custom software, hardware work that need to be done.
What about enclosure requirements? Because if it's a desert, I mean, it must be some kind of IP60 something. We don't have to prove that it's IP60 something, but it's maybe something we want to make sure we have to some extent. So maybe also have some simple tests that we can conduct before deployments. Otherwise, we are going to try everything, right?
I don't know what IP60 is. What is that?
The IP rating, so you have two numbers. The first number is about solid that can enter your design, and the second one is a liquid. Okay, so I think 6 is one of the highest number for solid. Okay, maybe the highest number. And after you have typically IP65, IP66, and so on. Okay, for us, liquid is maybe not so much a problem, but if there is rain in that desert, well, it becomes one. So I think the most important is to have a high IP rating for solid. Okay, so that we don't have any sand that enters the electronics and stuff like that, basically, or the motors as well, by the way.
So liquid, temperature, so all those kinds of like.
It's not temperature. So IP stands for ingress protection.
Okay.
Thank you.
And as Eric was saying, the first digit refers to solids and dust ingress. It even includes the lowest one is can you stick your finger inside of it, all the way down to dust penetrating the housing. And then the second one is water, and that ranges from not water resistant at all the way down to immersion. And there's a long list of water from the top, water from the sides at high pressure, water from below at high pressure. And the IP rating system is not the only system used to denote ingress protection, but it's the most common one.
Okay.
For your typical consumer product, IP68 is what you'll very commonly see. And that's I think that's the 1 meter submersion level, and dust proof, dust tight. This is what I'd say though. This part is really hard. It never sounds hard, and everybody thinks it's not that hard, but this part is always really hard. So this one is you can spend days, weeks in CAD, weeks doing testing, but this is one where I kind of be think about it a little bit, try to design, and then maybe take the garden hose and spray it. But besides that, just ship it, because there's gonna, like I said, there's gonna be things that you don't expect. Yeah.
Yes, I think informal is goes together exactly with what Joshua has just said. Okay, it's just to have at least some simple to think about it before putting, or otherwise it's going to get problems right away. Okay, and there are a lot of standard IDs. I mean, I don't have good memories of mechanical design, but when you want to put two things together, it shouldn't be just face to face, but with an angle. Okay, so that basically there be some kind of a natural joint, where not a joint. Well, some kind of shape when it's a kind of Tetris. Okay, so that they go well together, and then no sand can come in and stuff like that. Okay.
Yeah.
And after there are simple ideas okay, the next step is that you just add some packing, okay, on that one, you make a ridge and you put some packing, and then you have some level of protection against liquid, stuff like that. There's some list of design principles to move up the IP ladder, basically.
So since we're starting with a desert environment, if the goal is to get it out as quickly as possible, I assume really the minimum is dust and sand protection since it's a desert. But water, for example, is not that important. We want to be prepared for like a sudden unexpected rain shower, but other than that, we don't care that much about 1 meter immersion level of water protection.
I mean, we have had historic amounts of rain. So, including in the desert. So, yeah, all I'm getting at is he'd be surprised the stuff that with the ingress and things will work surprisingly well sometimes. So definitely, we can get the silicone and caulk it up and seal it up to the best of our ability. But there's a certain point where you just got to put it out in the field, and maybe a few of them die.
Nick, do you already have a sense of what material this should be built out of at all? Like aluminum, ABS, what?
I would really suggest, I think I would love for this to be like a kind of like a Roomba style all plastic robot that can either be printed 3D printed in-house or at a service bureau with something that's really easy commodity off the shelf to just replicate. Because especially it's so far it's small enough that the whole thing can be made out of one part. I think that'll keep it really simple.
What about temperature regulation? There's of course the material has to be chosen, but do we need a fan or we will need a fan, I'm sure, but other than that, is there...
So that's a great question, and so that gets immediately into the ingress stuff. The amount of funny business I've seen concerning ingress protection and thermal management, let me tell you. Here, I have an example I could show.
So
this is an example of a no budget, over the top. What happens if engineers just go for it with no constraint? So this is a camera. This is the camera. It was built for, this was hardware that Abundant Robotics created to harvest apples. So what do we have here? We have 2 flash lamps out of a traffic light automatic ticketing system, which generate a lot of heat. And they have very crazy power supplies, high voltage and stuff. But so what they did was, this box, it's fully enclosed because it needed to be IP rated. Because you see how dusty this is? So they made a sealed box. Okay, what happens when you make a sealed box? It gets really hot. It gets really hot in the box. So what they had to do was, you see, this is actually a heat sink inside the box. And then they had custom fans to force air over the heatsink inside the box. And then guess what's on the other side of that heatsink? Another heatsink on the outside of the box with fans, intense fans to flow air over that one. So why are there 2 heatsinks? This is to lower the thermal resistance of the walls of the box by having 2 heatsinks connected to each other. But all of that added immense cost, complexity, assembly, weight, just the whole list. Versus if you just vent the box, if you can, there are a lot of cases where you can't vent the box, but if you can just vent the box, then that solves a lot of these problems. So this is what I mean. It's IP rating sealed the whole thing. Okay, well, you can do that. But there are other problems that can occur. So this is an example of an extraordinarily over-engineered box that had all kinds of issues. I mean, look at all these crazy gaskets and stuff that they did, and you know,
So-
there are a lot of other approaches that could have been used.
Another way to do thermal management, I think, is actually just to do the mission design that way, where you have like autonomy logic that says, just don't try to operate when the temperature is like super hot. So for example, dawn and dusk or night. So in the daytime, you're doing something very simple, like just either sitting in the shade, or if it's not too hot, you go out and charge. And when it's cool enough, you operate. So you kind of like design your mission around simpler heating or management, because what is going to be the biggest heat source inside? It's going to be the motors, I'm guessing. When the motors are, yeah.
It's gonna be the compute. The compute will be the biggest.
So we should use the lizard brain to shut down the RPi when the sun is the hottest, and then the rest of the time you just run it during cool time. So that's another way to manage it, I guess.
Yeah. But
so if you split compute with the lizard and the higher level brain, it's implicitly we adopt a bit more like a subsumption architecture. Okay, and so something like shutting down the upper brain because it's too hot is typically what in subsumption architecture is about survival mode, basically, low level survival layer of the whole brain. Okay. So it's pretty standard, okay, in that line of thinking. So Joshua, I interrupted you.
oh no, not at all. Oh, and by the way, we need to use ASA. We can't use ABS. Yeah,
ASA?
yeah, ASA.
Wait, what is it?
Let me show you an example. This is a side project of mine. So this is a hummingbird feeder. So this is red ASA material. This is red ABS material. It used to be red.
Okay.
With the sun, the color just changes much.
Yeah, ABS is it slowly gets destroyed by UV. ASA is much more stable under UV exposure.
All right. So ASA it is. That simplifies things. First time hearing of it.
So just to be sure, the temperature properties are also similar in the sense that in the desert, ASA is just fine as well.
Yeah, ASA and ABS are otherwise pretty similar. They're in a similar family. Even the cost to print with them is all very similar through Service Bureau. It's just one is much more stable under UV exposure, and the other just can't do it over time.
All right.
Okay.
Going to build an ASA all plastic rover with RPi, and do we have a board choice for the lizard brain?
There is a power management board that directly fits as a hat, and it has an Arduino on it. So we could use that, and specifically made to turn off the RPi, it seems.
Do we want to use a RPi? Is that like the weapon of choice? Or something else?
I don't know, there is the call for RISC-V. Okay, so
But like, can we even get an RPi 4? Also, an RPi 4 uses like 5 watts. It's like some serious compute. It's like it's watts.
So I had a chat with Raspberry because we have a contract with them, and apparently now they are solving the availability issues, at least in the UK. Okay, so that's one thing. But there are a lot of alternatives to the plain Raspberry, right? I mean, there are all those equivalent boxes. Okay, there is a Orange Pi, Banana Pi, Odroid, all those boxes as well. Okay, but I think all of them have the same problem in terms of power.
Are there low power RPi boards that are not significantly compromised on compute? Like, how do you lower the power other than just like lowering capability?
Oh, you just need an efficient processor, right? So that's the most important thing, is selecting a chip that's very power efficient.
So maybe the way to do is backtrack from the minimum viable compute load. So what is the most computing it'll be doing at any one time? It'll be carrying telemetry, including video, running 2 motors. But the motors will have their independent power supply, but just controlling 2 motors, I guess, not running.
I'm just looking at eBay prices for any Raspberry Pi. It's all, yeah.
If you want to go with RPi 4, I'm not really using the one I have. I'm happy to donate it to this project, but I guess the availability seems downstream of these decisions, as in we can figure that out. What is it going to be computing at highest load? Because that should be the sizing of the processor. If it does complicated navigation, like SLAM or something, that's way more complex than, just hit an obstacle, back up, turn a little, random walk, that kind of like simple navigation will be lower load.
Right. And after it depends on the mission, because if it's about tracking radioactivity, it may be simple recognition algorithm, but if it's something like tracking plants and stuff like that, that would be more compute intensive, perhaps. But apparently, what you wrote is would be the minimum, the common set of features that we would expect, right?
All this thing can be done with an Arduino. Arduino has released a new board with a Cortex M33. So it's quite capable. I think it came, or at least they announced it 2 weeks ago.
I mean,
don't
yeah, there's a lot of other host targets besides Arduino, right? There's any number of boards we could use. But it's like, if you do actually, this is the question: do you want to run Linux? Do you want to run Linux? Because that's like the big brain versus the lizard brain. Like, we could run Linux on the lizard brain, but that's a little bit, that can get a little bit more interesting. I would suggest it's like, if you do want to run Linux, then run Linux on the big brain. The other really big question is, can the lizard brain also actuate? Is that in control of the actuators, or is that only the big brain? And the lizard brain is really only doing power management.
That's something is open to discussion, but seems to me the lizard brain here should be about basically low-level control and survival, meaning that it doesn't move. Okay, so I don't know about other actuators, but at least it doesn't move, because that would be basically the lizard brain here is to control survival. To turn off the big brain when we don't have enough current, or when we the rover turns into some kind of charge mode or something like that. So in that sense, I don't see any problem with the lizard brain and not controlling the motors, for example.
Do you even need a big brain here? Do you need Linux? Do we need that, or should we run something a little bit more lower level, like Zephyr? Can we get away running Zephyr?
Yes, and so that's in line with what you mentioned earlier, that to release earlier something simpler. Okay, totally agree that first we don't need a big brain. Okay? Because the thing that if we look at what Red did last year, with his mini car, which has just an MCU on it. Maybe it was an Arduino, by the way. He did quite a few things with it. Huh? I mean, there were so first remote control. There was telemetry. There was also he could transfer imagery as well. Okay. Remember, he had problems about the frame buffer and so on. Okay, to solve and to control the motors as well. So it seems to me that in a kind of onion design. Here we have an advantage that the Lisa brain is at the base, and on top of it we can put a bigger compute. But we should be able to work without the bigger compute. The bigger compute just adds more capabilities, right?
Yeah.
Yeah, but right now the question is, do we want to use off-the-shelf components or not? If we do custom design, we can do everything without Linux. That's like, if we are trying to keep it off the shelf, then we will have to choose. Like, we have limited options. Of course, the entire thing here can be done without any Linux. But then, like, it requires some custom design.
I mean, I don't know that the hardware design is custom versus not custom with or without Linux. The Linux question is more about the software stack. Like, is that more ergonomic? Is that easier to do? Like, as this is like a small example. Let's say, because this is actually the real case. Let's say it turns out if we're sending camera data over a limited data and bandwidth link, let's say it's LTE, let's say it's LoRa, it could be APRS on the ham frequencies, could be satellite. We need to run some serious compression, some really serious compression on whatever sensor data that we're capturing, especially cameras. So re-implementing MPEG on the bare metal micro is going to be a lot more work than running OpenCV to compress all the images, or FFmpeg. So if you want FFmpeg to compress all your data and rescale all your images, Linux is really nice. Really nice.
But we can have also some kind of a degraded mode that first with an MCU there is no video, for example. It's just images. Okay? If we really need to transfer images, okay? And the proof is that the Red did it, okay, with just an MCU. And the thing that if in the mission we really want video, then this is when we require the additional big brain with Linux, where we take advantage of all that power, basically. Would it make sense this way? So when we turn on the fire, there are things we just can't do. That's about it.
Yeah, but it's like if the mission is to capture camera data, and maybe we don't require getting camera telemetry during the mission, but I would think if you want to do interesting things with that on the server, we would need to send the camera data on the wireless link. So that necessitates getting into this, like, okay, is it actually practical to send camera data over this link? And then how much can we compress it? Because otherwise it becomes very prohibitive. Because then you're either being picky and choosy about what images that you send, which requires more edge compute, versus being low edge compute and sending all the images and just compressing them really well.
So right, I think it's necessary, but this is not the continuous mode of operation of the rover. That when it has enough power to do it, yes, it does it. But at some point, it turns into charge mode or night mode or something like that, and so all that video thing. If we look at the power budget and so on, is too much, and so we turn it off, and we just during the period where it's turned off, we just can't do it. It was my understanding of what we are talking about, basically. The Lisa brain is about managing basically this cycle where there is enough memory, so there is enough power, so we can work at full capabilities, so including dealing with videos, And at some point, we don't have enough power, so we just turn off what is not necessary for survival. So the big brain and so on. And we move in charge mode or whatever.
So it sounds like you're advocating for the lizard brain to only handle power management. So effectively, we just have a power manager, and then we do have a full Linux compute and all that. Like, is that what you're saying? Because that is actually very simple. Like, having the big brain simplifies a lot if the lizard brain is doing less, because yeah, I don't know how many people on the project are familiar with Zephyr development or dealing with a bit more bare metal, not bare metal, but free RTOS or basic operating system. That's a whole skill set that I don't know if anybody in the group has to contribute.
Yeah, I can do that. It's not a.
Okay, so yeah, if there's somebody that wants to contribute the firmware piece, then that's feasible. Versus having a full Linux box, that's like much more accessible to a wider group of people.
And so you're suggesting basically to have just to have no lizard brain, but just to have a full box.
Yeah, but this is the thing. Like, you will want to be able to, because this is the other thing that's really, really nice about having connectivity is doing OTA.
Yeah.
So if we have the OTA capability, that makes the lizard brain really nice, because you can also OTA the lizard brain and modify the power management behavior. Versus if you have some kind of like hard-coded power manager, you have no way to control the power management, which is not as nice, right? So that's the other nice thing about the OTA and the connectivity is that you can kind of like build the plane as you're falling, because like you can ship the hardware, but then the firmware can be completely behind, and that's fine.
Right. Yeah, I see. Yes. So basically, there is a lack of symmetry. By symmetry, I mean that if the lizard brain is a fundamental, then we can't change it. But if it's not fundamental, it draws more power. Okay.
Well, there are ways to change the firmware over the air too, right? Like, why would that be a problem?
It depends on how we have the modem connected to the system. And then we also have the risk of like bricking stuff. Right. So
there are lots of tools available or software available, like OTA softwares available these days. So I don't think it's a big issue.
Depends on the architecture. Like, if the modem is talking directly to the lizard brain MCU, that's true. But if it's talking to the full computer, that's way riskier, because then you're doing stuff like updating your power manager while the device controlled by the power manager is running. And there's all kinds of race conditions and stuff. So this is what I'm getting at, is like all these things begin to emerge, right, depending on the architecture and how you approach it, even with the off-the-shelf stuff. But what I would say is, like, this is all driven by the mission. So if we need to do image processing, then we have to have Linux, then we have to have a big brain, then so on and so forth. Versus if we say we don't need a big brain, we don't need Linux, then okay, that makes things a lot easier, because then we just get a beefy MCU and run Zephyr, and we're done. Can we complete this mission with ESP32 cam alone?
Yeah, I think so, yes. But then it becomes less accessible to many, because you have to know what's going on underneath. It's not as like as you said, accessible as Linux. It's easier, way easier with Linux, but then it consumes more power.
I love that we're having like robot problems now. This is like such a quintessential robot problems.
But I think we can do the entire thing with the ESP32.
So now are we prioritizing accessibility or complexity?
Well, I would prefer accessibility in the beginning, and then we can iterate if you want to make it more complex. So first, it's like we try to ship something with as fast as we can. So that means off the shelf and accessibility.
By accessibility, do you mean cheap enough for a lot of people to build it, or?
No, like easy enough for a lot of.
Oh, okay. So, and ESP32 is going to be easier for people to program than full Linux computer.
I would say
Opposite.
Linux would be easier.
Yeah, the opposite.
Okay, so if you want accessibility, you want a Linux computer.
Yeah.
But you'll need more power, right?
Yeah.
I'm inclined to try and design around enough power to run an ARPi-4 because it's obvious you're going to end up there in the future one way or the other. Like, so why go to the trouble of like figuring out low power operations if you know you're going to end up with slightly higher power, which means actually it would be better to put more effort and thought into higher power supply. So,
Well, it seems like the BeagleBone has like different power modes, and you could use the small MCU on the silicon to run the power manager, and then turn off the bigger Linux core, and then you turn it on back.
Oh man, the PRU. So
Yeah, but
is it-
yeah, so that is also like less accessible, I would say.
that's
compared-
like, man, that's in there. That's some stuff. Yeah, that's like,
I do have to go in a few minutes, so we should probably
Yes,
wrap
yeah.
up. So, what's the?
this is what I would suggest. I think the compute should be a modular add-on. So the lizard brain should be able to control everything, but then it can turn on its big brain and have big brain thoughts. And maybe the camera is only connected to the big brain, but this allows the system to be much more modular, which Mayer will love. And this is actually how a lot of things do it. Like even Boston Dynamics Spot robot, you are not allowed to do any compute on the robot. That's the lizard brain that supports the locomotion and balancing. It has a backpack that you install on the back of the Spot robot dog, which allows you to do your own compute workloads. So we could do a similar approach where the lizard brain is what talks to the modem. It moves all the data around, except for the cameras, controls the motors, controls the power, but then it can fire up the ARPi and do video processing.
And I missed that part of the discussion, but can the lizard brain, whatever ESP32 or whatever you use for it, how much can it do video? Can it just take photos and store them and wait for the ARPi to come online and send it or process it?
Well, we can always use the SD card, right?
Yep.
Okay.
Yeah.
So it's not that the camera is offline when the big computer is offline. It's just that you can do very limited things with photography while the big computer is offline, right?
Yeah, so we store it somewhere, and then when we want to process it, we turn on the big computer.
Okay.
We have to remember that Red's car was an MCU too. Okay, it was a lizard brain only, and he could do quite a few things, including sending images, not videos, but images, frames, basically, right?
Yeah.
Yeah, but could it compress those images?
Yes. Yeah.
Did he compress it? I thought he was sending very small.
No, it was a simple camera, so not much compression was needed.
Okay. Yeah.
Yeah, that's what I'm saying. The compression is non-trivial. So yeah, maybe okay, so we could plan for the next meeting. I think that would be a good system block diagram day. So we would start to go from this, and then I'd be happy to just live interactive system block diagram in Lucidchart or something. And we'll lay out the connections electrically, mechanically, and in terms of like energy flow.
Okay. Sounds good. So that sounds like a good stopping point.